is cosine square omega t plus phi plus sine square omega t plus phi. Ladies and gentlemen, what is this? If you can tell me, Dominguez, what's this, Dominguez? Dominguez, what's this? What's the cosine square plus sine square? Huh? Oh, Vivian, what's that? What is it? Vivian is better than So, man is the weaker sex. I will tell you later on. Woman is the stronger sex. From physics point of view. From physics point of view. Okay? We'll tell you more story about it. So, this is equal to 1.5 Ka squared. So, the total mechanical energy is equal to 1.5 Ka squared. What is K? Hooke's law. Hooke's law, the spring constant. What's A? A is the amplitude. Amplitude squared. So K is constant, A is constant. So the whole thing is constant. So that's how beautiful the map is on the section 12.3. Very nice. Okay, so now we move on to the section 12.4. So we want to copy the success. So we want to lump the simple pendulum. Again, is simple harmonic motion. We did the drawing for you last time. That means when it swings back and forth, it becomes oscillation and it is little sine curve. Now we want to mathematically prove that to you. This is the simple pendulum. Simple pendulum. What is a simple pendulum? Simple pendulum is like what I just showed you. This is simple pendulum. Oscillation like this. This is simple pendulum. Now, for you just cannot imagine this simple pendulum can be expressed sine and cosine function. And pretty soon you will find out that basically is true. So we're talking about simple pendulum. So we like to do this now. Simple pendulum is basically something sticking and have this on. So basically, there's a force push it down, in which case is equal to mg. And this is a force in this direction, in these cases, and that is a tangential force in that direction. This angle is theta, associated with this angle is theta. Ft. Ft is equal to mat, tangential velocity. So this is the case. So Ft equal to mat, okay, is s. So Ft is equal to the force is pushing down in this direction. So this component is theta. So this Ft equal to minus mg times sine theta. Now, what is At then? At is the derivative 2 times d2s dt2. Yeah, again, it's a simple algebra and derivative. So we like to substitute this. Substitute the information on both sides, then we will have d2s dt2 times m equal to minus mg times sine theta. Okay, so we go back to something called, this is L and S is in here. Now, in physics, we like to express why it makes life much easier. If you look at this, S is basically equal to L times theta radian. Okay, from your algebra, from your trigonometry. So okay, so we substitute that equal to m d2 L times theta dt2 equal to minus m g times sine theta. So m cancel out. So we got a very nice form or equation. So d, okay, L d2 theta dt2 equal to minus g times sine theta. So we almost got there. Now we do another nice thing about this. Is minus g divided by L times sine theta. Sine theta. Now we takes very good physics to think about this. So that's a sine theta. This is a theta. It's nothing close to d2x dt2 minus omega squared x. These two in here is different function. Now, in order to go back to the same function, you have to take approximation. That's what physics does. Physics. Most of the physics, like Raymond Lu, are very lazy. But we take some assumption called educated assumption. So what is this can make this function and this function identical? Okay, so now what it was before is very easy. We usually have a trigonometry function table. So we just look at it. Lo and behold, when the angle theta is smaller than 5 degrees, angle theta smaller than 5 degrees, then if you express sine of theta radian is equal to theta radian. Okay, we don't want to say exactly equal, at least approximate, all the way to what they call at least 6 decimal points are the same. Now, this is a major breakthrough from this equation. So, in case we want to do this physics experiment, when we do the simple pendulum, want the swinging angle smaller than 5 degrees. So now you go to, there's one place, it's called Observatory in Los Angeles. What is that observatory? The name of the observatory? Griffith Park, yeah. The Griffith Park Observatory is a very nice place to go, especially for younger generation. Very romantic. Now if I take my wife there, before when I take her to down there, oh God, it's so enjoyable. Oh, look at all the city light and all those things. So for you guys, you should have that kind of feeling. Go down there. Now in the Great Park Observatory, have one thing is always there is a simple pendulum. The simple pendulum is very, very long. And then when it swings, the angle is very small. The longer the L is, the more accurate it is. That simple pendulum clock is very accurate. Okay, to 1,000th per second. So very, very accurate. So using this, then you have d2 theta, dt2 equal to minus g divided by L times theta. Ladies and gentlemen, this representing simple harmonic motion for simple pendulum. And then we have to go back to the basic equation. Basic simple harmonic motion equation. That is equal to d2x dt2 equal to minus omega square x. So if you compare this, compare that, so you have a very nice setup, in which cases omega square equal to g divided by L, or omega is equal to square root of g divided by L. So the period t equal to 2 pi L divided by g. L divided by g. So the mass is not taken into account. Again, there's a period there. So we will do the experiment Monday and do that. So now the next one is section 12.5. Now instead of a simple pendulum, now you have something called what we call the physical pendulum. You have solid now, like this, oscillating. And using the same math, this leave to the student to study on your own, and 12.5 is getting the same form for the physical pendulum very nicely. So section 12.5 is finished, and then the chapter 12 is done.